Hello everyone, this is KP the Math G. I'm just running into all kinds of things this morning. And so anyway, be that as it may, we are dealing with this problem here. And we did parts A and B the other day. So I wanted to finish up with C and D today. I really like this problem. I like all the questions for this problem. It's a very good four-part problem. I really like it very much. All right, so let's get back to where it was. If you haven't looked at this, this is a table that deals with an ice sculpture that melts. It's modeled as a cone. And it's inverted. See, it's a cone. All right, that maintains its conical shape as it decreases in size. The base radius is twice differential. It's a twice differential function of r. R at t is measured in centimeters. T is in time over the interval from 0 to 12, including 0 and 12 both. Alright, so we're going to have to go back and forth to do part C and maybe even a little bit of part D, but we can do it. It's not too bad. Let's go ahead and get started because part D is going to take a little while to do this. Okay. By the way, incidentally, this is St. Patrick's Day. Yes. March the 17th, so I got my green on today. Alright, so anyway, let's get started. It says approximate the definite integral from 0 to 12 r prime of t dt using a Riemann sum. Okay, it's a right Riemann sum. We can't just say Riemann sum, it's a right Riemann sum. So let's get into this one. I'm hoping. Let's look over here. Back over here. Now, when you deal with a right Riemann sum, you totally ignore this last number right here. Okay, you're taking these four. And what you want to do is look up here and see what delta t is. Delta t is from 0 to 3, so that's 3 units from here. Alright, this one is 3 units. From 3 to 7 is 4 units. Alright, and then from 7 to 10 is back down to 3 units. And then from 10 to 12 is 2 units. So what we're going to do is multiply these 4 numbers by these 4 numbers in that particular order. Okay, the negative 5.0 goes with the 3, the negative 4.4 with 4, negative 3.8 with 3, negative 3.5 with 2. Okay, and if it had been a left, we would have ignored this one and taken these 4 numbers using these same 4 numbers as well. Okay, alright, and I have multiple videos. This is going to be my 154th video, and I've got multiple videos on all the types of estimation. So anyway, let's go ahead and get started. We're going to multiply. Let's just go ahead and say we're going to keep coming back and forth anyway. So let's take a look at this. We're going to look at from 0 to 12, and r prime at t dt is approximately equal to, and you have to say approximately equal to. I think my red's going to run out of ink, so we'll just go back to the blue. So let's see, the first two we're going to look at, we're going to look at 3 and times negative 5. Okay, so negative 5.0 times 3. Alright, let's look at the next two. Alright, negative 4, we'll check it off as we go. Negative 4.4 times 4. Alright, negative 4.4 times 4. Plus, next one now, let's keep going back. Negative 3.8 times 3. Negative 3.8 times 3. Negative 3.8 times 3. And then finally, we're going to get negative 3.5 times 2. Okay. Let's put it down here. Plus negative 3.5 times 2. Let's double check. Negative 5.0 times 3. Negative 4.4 times 4. Negative 3.8 times 3. Negative 3.5 times 2. Alright. Negative 5.0 times 3. Negative 4.4 times 4. Negative 3.8 times 3. And negative 3.5 times 2. And that's how you do a right Riemann sum. Now, let's just see what this equals to. We're going to finish this off. Negative 5 times 3 is negative 15. If you want to put the 0.0 there, you can. That's all right. Negative 4.4 times 4. 4 times 4 is 16. 4 times 4 is 16, and 1 is 17. Put a negative sign. Don't forget that. Negative 17.6. 3 times 8 is 24. 3 times 3 is 9. 10, 11. So negative 11.4. Okay. And then plus negative 3.5 times 2 is just negative 7. So negative 7.0 if you want to do that. Alright. And what I like to do is group these two together and group these two together. So negative 15 plus negative 7 is negative 22.0, and then plus, and then of course 6 plus 4 is 10. 7 plus 1 is 8, plus 1 is 9. Alright, so 9, and then 1 plus 1 is 2, so negative 29.0. So all we have to do is add them up, and now let's see, 0.0, 2 and 9 is 11, carry 1, and then 2 plus 2 is 4, and 1 is 5, and that is negative 51.0. I don't think you have to worry about putting units there, but if you had to, since this was centimeters per day, you would just end up with just centimeters, I believe, or I do believe that's right. Alright, so okay, that's what you really have to do. In either one of these, if this was a left or a right, just keep in mind, since this is a right, you're just going to leave off this leftmost one, and then you're going to just multiply this, and you just got to keep it in the order, okay? You can work backwards if you want to. You could have started with this one, and then this one, and then this one, and then this one, either way. But that is really what you're saying. These are all delta T, alright, units here. Alright, and that takes care of that. You do not have to have the units on this one. I do believe that's correct. Now, this one's going to take a while, so let's go ahead and get started with part D. I really like this. And we're going to need the table one more time, and I'll show you why we'll need it in just a moment. Now, let's just abbreviate as much as possible because we're going to need all the room we can get. What we're trying to do is, now we have to realize what we're looking for here is this is a cone, remember. Now the volume of a cone, let's put that down a little bit later. We got the volume of a cone, but now it says the height of the cone. The height decreases. I'm just going to decreases. All right, decreases at a rate. All right, now it's going to be the decreasing at a rate of 2 centimeters per day. Now remember that the height is decreasing at a rate. So it's not. This is not looking at height. It's the height that the height is decreasing at a rate. So keep in mind that's rate. So that would be dH. Hold on. Bear with me. I'm just going to do it like this. dH over dt. Now we know that that's really, it's decreasing. You've got to throw that negative sign in there. If you don't, you're lost from the start. Now dH over dt. Height is decreasing. All right, then we have R is equal to 100 centimeters, while H is equal to 50 centimeters. Okay. So it's a big wide cone, and the height is half the size of the radius. Okay. All right, so there we go. And we see that there's something else that we need to keep in mind. It says find the rate of change. Bear with me. All right, of the volume. Rate of change of the volume. Now let's stop right there. What is the rate of change of the volume? That's right. We're looking for dV, and that's what you got to learn. What are we looking for? Well, we're looking for dV over dt. All right. Now, at time t is equal to 3 days. All right. Now, what we also have to do, let's go ahead and get started with this. We know that V is equal to 1/3 pi r squared h. All right, we have something missing here, but I'm going to show you in just a minute where we're going to find the missing part. This is important right here at time t equals 3 days. And what part have we not found yet? What part do we not know? If we're looking for dV over dt, what part are we missing here? We've got dH over dt. Oh yeah, so dr over dt. And what we got to do is, in this particular case, this is where it really gets, you have to pay attention to this. This after 3 days, or at 3 days, because you have a table. Your table at 3 days, is negative 5.0. So, all right, so R prime at 3, or dr over dt is equal to, back it up again, negative 5. When t is 3, r prime at t, which is dr over dt, is negative 5.0. And that's the one thing that if you're not very careful, you will just forget that, and you won't know what to do with that. Now, you don't have to really put units here. Now, remember, it is negative. Just like this is negative here, you have to get those signs correct. Otherwise, you're going to miss your problem. Okay, make sure you get your now let's look. We got usually what happens here is what I like to do is I like to say, well, R over H is equal to let's see, R is 100 and H is 50. This is a ratio. Sometimes you can do that. But the problem is we can't do that. Why not? Well, here's the thing. dH over dt is constant. It's negative 2. And I'm thinking it's negative 2 throughout the melting process. That's what we're given here, at least here in this problem, right? But now what about dr over dt? Negative 6.1, negative 5, negative 4.4. At different times, it's different, isn't it? It's not uniform throughout. Okay? And because of this fluctuation here, okay, we cannot set up a ratio here. Oh, it'd be nice if we could, but we can't. So this is not constant here. It's not the same number throughout, is it? All right, so that's what we are up against. So we cannot at any time, let me look back. Yeah. We cannot at any time do anything like that. And my dog is barking at something. Hold on just for a second. Be right back. Hush! What are you barking at? Hush! Sit down and be quiet. Hush! Is somebody at the door? Hush! Oh, that thing fell down. That's all it was. The box fell over. The wind blew it over. I am not going to erase this video over my dog barking. A box fell over. It's a pretty heavy box. It fell over on the porch, and the dog went berserk. Which, that's what dogs do, right? Okay, all right. Now, we cannot set up a ratio. Now, that's what we were just saying a while ago. We cannot do that. So we're going to have to take the derivative of this, aren't we? And we're going to have to leave both R and H in there. Sometimes we express R in place of H, and sometimes we express H in place of R, don't we? We can't do that here. All right, so let's go ahead and start. This is a product rule, so let's just get the derivative of the left side, dV over dt. All right, now it's the first, all of this, times the derivative of the second. And the derivative of H is 1, but it's 1 times dH over dt. Got to remember that. When you take the derivative of this and you have two variables, you have to do this in this form, this fashion. Now remember, that is plus, all right, the first times the derivative of the second, plus the second times the derivative of the first. So that's 2 times 1/3, 2 times 1/3 pi r. And remember, we got to tack on, you know, we've got to take that derivative too. So there's where the dr over dt. Cannot leave that out. That's so important that you remember that right there. So now we can find everything because we have everything here. Okay. This is just the only way. This is the only way that this can be done, and you can set this up probably any way like that in most problems. All right, so let's go ahead and deal with this. R is 100. Pi times 100 squared. dH over dt is -2 times -2. Okay. All right, now plus h. H is 50, is it not? So 50 times 2 times 1/3 times pi times r, which is 100. Now dr over dt is -5. And that's where you get that from the table. All right, this came from the table. From the table. Right here. All right, you had to pull that out to get that. So now you have everything accounted for. And then when we get down to here, this is going to be equal to now. Let's put everything over 3 here. All right, 3 is going to be down here. That's my denominator. This is everything's up here in the numerator. All right, so let's go ahead. 100 squared is 1. Just tack on a couple more zeros, 10,000, and then we're going to put the pi on the end times -2, which is -2,000. All right there. -20,000, I mean, over pi over 3. -20,000 pi over 3. All right, here we go again over 3. All right, 50 times 2 is 100. All right, 100 times 100. So 100 times 100. Again, we're going to multiply that and get, let's see, again, 1, 0, 0, 0, 0. And of course, we got to multiply that by -5. So 10,000, 100 times 100, this is 100 here. 100 times 100 is 10,000, and then 10,000 times -5 is -5,000. All right, -50,000. I don't know why I keep saying 5,000. And then tack on the pi at the end, okay? So now when you add the two, both have like signs, so we can add these up. So this is -70,000 pi over 3. And if we want to put our units down, that's going to be in cubic centimeters. Remember, volume is always in cubic centimeters per day. Alright, there it is, cubic centimeters per day. Alright, now that's what we had to do. This is the product rule. The first times the derivative of the second. Remember, derivative of h is just 1, but dh over dt. When you have two variables, I want to say that's taking the derivative implicitly. Okay, I believe I'm right about that. And then plus the second times the derivative of the first, and then all you have to do, this is all the derivative of the first. The 2 comes in front. I could have done 2 times 1/3 and made that 2/3 right off the bat, but that's okay. And then when you get down to r, then you got to tack that dr over dt down there. Just don't forget, these are little bitty nuances that you just got to remember. You got to get this from the table here. You know, you got to remember how to do something, you know, by the product rule. And then again, h is just really dh over dt. This one now is dr over dt when you take the derivative there. And then just plug the numbers in, put them all together, and there it is right there. That is the answer. That is the answer. Okay. And of course, if the height and the and the radius are all decreasing, certainly the rate of decrease in the volume is going to be this. It's going to be a negative number. Okay, there it is. Alright, and if you say decreasing at a rate, then you don't put the negative sign there. Okay, if you say dV over dt is decreasing at a rate, you simply put this down without the negative signs, because the decreasing is already the negative sign. Decreasing at a rate. Okay, so just make sure you do that correctly. Either way, if you just leave it like this, you're fine, you're good. Alright, so there it is. I like doing these. This is very important that we understand how to interpret this and how to take the derivative of this here. Alright, the Riemann sum, I think you can get that. We've already looked at that just before. Remember, Riemann, this number, these four numbers here. Alright, not these up here, these down here, times these delta t's. Alright, add them up, sum them up, and you got it. I think that was negative 51, wasn't it? Okay, negative 51.0, and then of course right here, negative 70,000 pi over 3 cubic centimeters per day. Alright, there it is. Alright, if it just said volume, it would just be cubic centimeters, but this is a rate, so cubic centimeters per day. Alright, there it is right there. There it is. Sorry about the dog barking. We do have a dog in the house, and she's a pretty dog, and maybe someday I'll get a chance, I'll bring her in here and you can see the dog that was barking here on St. Patrick's Day, okay, over a box that fell over on the front porch, okay. Alright, anyway, KP the Math G getting ready to sign off. Please hit that subscribe button if you would like to. If you'd like to make a comment, please make a comment. And also, if you would like to hit that that like button. I love likes, a bunch of likes. So anyway, I always get a smile. I always repeat the same thing over and over, don't I? So I get a smile on my face when I get that. But anyway, this is for you. This is not for my glory. Believe me, it's not for my glory at all. All right, KP the Math G signing off. Ladies and gentlemen, have a great day.